For video signals, we should need a range of 4.2 megahertz bandwidth. For TV signals, we should need a range of 6 megahertz. So initially we have discussed about the sound waves, it is 20 kilohertz, and the speeches audible range is 3000 Hz to 3100 Hz. Means it is the bandwidth range for all different types of signals. Maybe it is a video, audio, data, whatever it may be. So what is the nature to understand these things? Sometimes the waves which are produced may be discrete or may be single valued. In case of discreteness, they can be decomposed by the superimposition of the different waves, maybe overtones. So there is a graph which we can understand the overlapping of the overtones and their frequency ranges. So we will see the graph now. Now we will see with respect to the time and with respect to the variation in the voltage, what is the change in the shape of the wave. See the first wave A, which is in a rectangular shape. A is rectangular wave. Sometimes in the wave propagation, there may be a superimposition of waves with respect to their fundamental mode and first harmonic, second harmonic. So this A is the rectangular wave. Sometimes the wave propagates from rectangular to the distortions. Distortions means sometimes the superimposition of a fundamental wave, first harmonic, second harmonic, third harmonic. Whenever the harmonics are increasing, frequency is increasing. Number of oscillations per 1 second will increase and the wave is propagating in a form of transverse wave. So see the A is shaped like a rectangular, that is a primary wave. See the B1, first wave, primary wave we can say. See the wave C, this one, wave C, which is coated with the green color. A is blue, next B is the primary wave, A is the rectangular wave, so the B is the primary wave, the first harmonic, we can see it is. See the first loop, so it's the first loop also. If you see the C, it is not the first loop, see the how many loops it is creating. The green one. The green one is the C. So the C is first harmonic, fundamental frequency, plus second harmonic. Because it is creating the two loops per unit time. Where B is first loop or fundamental mode. See the D1, it is fundamental plus second harmonic plus third harmonic. Fundamental frequency plus second harmonic plus third harmonic. So these type of overlappings can create the larger amplitude and the interference of the waves at this point and at this point. With respect to that, we can see the higher frequency, higher amplitude, and this will be the resulting wave pattern. So the fundamental plus the distortions. The fundamental is expressed by nu naught, second harmonic 2 nu naught, third harmonic 3 nu naught up to n nu naught. This is the wave propagation we can be done with the communication systems. Now we will see the different band ranges or frequency ranges for different communication systems and setups. See the standard AM broadcast. AM means amplitude modulation. For that amplitude modulation broadcasting, the frequency band should be 540 kilohertz to 1600 kilohertz. Mostly this amplitude modulated broadcasting will be in radios. Next one, frequency modulation broadcast. Frequency modulated broadcasting. It is up to 88 to 108 megahertz. This is the megahertz range. So the famous FM channels what we are listening every day, 93.5, 98.3, 91.1, all these are in the MH range, means megahertz range, and megahertz range, that to be the limitations of 88 to 108. That is the band range or frequency band of the FM broadcasting. Next one, television. Television also having 4 sub frequency bands. One is very high frequency region, 54 to 72 megahertz. What is the need of 4 sub classifications in the television? Television not only sending the messages in form of vocal, they are sending the audio and video, pictures, data. Now everything is in becoming colorized, means many colors are there for different channels. Everyone is watching the colorful channels only. So they should emit the particular colors to the receiver. So for that purpose, high frequency ranges is to send the musical notes. The low frequencies is useful to send the sound notes, and the remaining are useful to send the data. So these things we already discussed, and that purpose is useful in television communications. This is first one is very high frequency region. Second one 76 to 88 megahertz is TV, the audio wave. 174 to 216 megahertz is ultra high frequency. And 420 to 890 megahertz is again TV. These 4 frequencies have different usages to send the audio files, video files, data files, all these at a time. So by mixing a frequency as a single wave, we can see the television broadcasting. Next we will see the ranges of the other communication systems. See the next list of the services with respect to the frequency bands. Cellular mobile radio, means the cell phone signals, the mobile signals. The frequency bands for the mobile technology and the mobile communication system is 896 to 901 megahertz. It is from mobile to base station, the nearest base station, which is acting as a tower receiver. From there to customer, 840 to 935 megahertz. It is again from base stations to mobile. So this is the frequency range for the mobile communications or cellular mobile radio wave communication. Next one, satellite communication. Satellite communications range is 5.925 to 6.425 gigahertz. GHz means gigahertz. One gigahertz is equal to 10 to the power of 9 hertz. 9 hertz. So it is gigahertz. This is for uplink frequency. So suppose if you want to see the transmission of signals of any channel, a newly launched channel, so they will give some uplink frequency as well as downlink frequency for that particular cable operator or the dish. So this is the uplink frequency for the satellite communication. Next 3.7 to 4.2 gigahertz is the downlink frequency. So this is the basic information about the different services under the frequency bands and their uses. Next we will see the communication takes place, what are the different waves which are including in the transmission of the communication waves. Next we will see the propagation of electromagnetic waves. Where EM means electromagnetic. The propagation of electromagnetic waves can travel through vacuum also, but the frequency and wavelength is really very important for the transmission. So whenever an electromagnetic wave is traveling from the source to receiver, it goes with the different variations. So before this concept, we have discussed about attenuation, modification, modulation, many things we have discussed about the transmission of the electromagnetic waves. So these all things it should face, this electromagnetic wave should face, and with respect to that it should reach the receiver. In case of this middle effects, means the effects which are happened in the middle, there may be a possibility for the loss of strength in electromagnetic wave. That strength loss should be replaced with modulation. These things we know. But here, if you want to see the clear picture of the propagation of electromagnetic waves, these waves are classified into three types of propagation. First one is ground wave. Second one is sky wave. Third one is space wave. So what is the physical significance of each wave? Where it will works? What is the frequency range of that? Why these electromagnetic waves are classified into these three types for the propagation? We are going to see now.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.